thank you for joining us. Just a minute, sir. Before your talk, I would like to introduce you to our audience. Here, sir, are the faculty members across other universities, state universities and private universities, and also colleges are available. And apart from this live link, we are also sharing the YouTube link for the benefit of the students across state. So there is also one facility we are giving. And we will keep this in our LMS also, AppShare LMS, for further viewing of all our faculty as well as students for their greater benefit. So all our faculty members, I welcome you all once again, and I thank you for joining. And also I request you all to share this link to your faculty, concerned faculty across your institutions, so that many more faculty will get benefited. Here is a brief introduction of today's resource person. It is actually very elaborate biodata, but I would like to read out very important and few points for the purpose of saving time. So Sri Harsha Bhargavabhushanam is a prolific academician. His professional, first I would like to summarize his educational qualification. He is a PhD in computational and applied mathematics from the University of Texas at Austin. And his MS is from Massachusetts University, Amherst, that is MS Applied Mathematics, MS Electrical Engineering. I pursued these two programs, that is Master of Science around 2000 and 2004. And he did his PhD around from 2004 to 2008. He's a strategist and his initiatives driven and accomplished data and AI expert with extensive experience in senior level of leadership management and stakeholder management. His project delivery and engineering and advanced machine learning across 17 years of his postdoctoral work. He's also postdoc. He's a strategist in AI and ML that successfully led the design and delivery of AI first strategy for Experian Football and BP, that is world's very favorite, most popular British Petroleum. Externally and internally, he is also worked at BP, BGSS, Experian Football and Pros, recognized data and AI leader. BBC also recognized his expertise in article with section quoting by my work at a bank. External engagements at premier AI events such as Financial Times Panelist, London Tech Week, Keynote, and International Energy Agency in Paris, that is Global Leader Roundtable. Worked within leading organizations like British Petroleum, BGSS, Fidelity International Limited, Lloyd Banking Group, Waitrose, National Rail, NATS, that is National Air Traffic Services for UK, and Experian Football and Pros. And he's a pedigree of AL and ML technical pedigree, rigorously academically trained, a physicist. His background is physics and mathematics. He's a great Olympian for both mathematics as well as physics. And PhD in computational and applied mathematics from the University of Texas. Seminal contribution to Susan research techniques. And published multiple peer-reviewed publications in the prestigious journals in the field of computational physics. And the Society of Industrial and Applied Mathematics Awards. A finalist Indian National Mathematical Olympiad, and a finalist Ramones Institute of Physics and Math Talent Search. And AML experimentation and delivery, pioneered improvements and innovation with data and ML products at a UK retail bank, delivering value to senior management within 25 million European pounds. He uploads for the key backbook products. Technical hands-on initiatives help deliver over 100 million US dollars of incremental revenue on customer-facing services in BP. Increased the product buying patterns by 15% for a UK's top-tier grocery retailer by offering the right product at the right time. He achieved 3 to 5% fuel savings via better flight planning for National Air Traffic Services UK and delivered measurable value of 3 to 4% revenue uplifts for a EU shoe retailer. Successfully delivered up to 5% revenue uplift opportunities and up to 2% cost saving opportunities around staff allocation and till optimization for top 100 US, UK, EMEA, digital media, grocery, fashion, DIE, jewelry, retailer, etc. And successfully delivered ROI ranging from 80% price improvements for a Forbes 20 company, 200 basis point lift for a medical distributor translating to approximately $60 million in value and $15 million in potential margin lift for a paper manufacturer. And delivered value through reusable, scalable, and industrialized innovation across service. Distribution, manufacturing, and oil and gas sectors, Fortune 100 and 300 companies, to the tune of 3 to 4% revenue uplifts for global medical supplier. And 1 to 2% cost saving opportunities at 80% price improvements in service products and 200 base point improvements for manufacturer. His AI governance worked with legal, ethical compliance teams to help implement responsible AI frameworks to meet regulatory requirements. Co-developed policy and procedures for enterprise-wide AI governance, led technical development of MLOps framework, data and model controls. AI culture, a proven leader in building and delivering with high-performing teams from ground up, delivered enterprise-wide AI strategies with actionable analytical insights to deliver business value. The board, CEO, CFO, CTO, directors of senior leadership, while building and leading data science projects with team of 15 plus high performers. So there's a big biodata, and he head of the data science and AI at BP from 2022 onwards. He also headed data science at BGSS from February 16 to 2022. He's a lead data scientist at Experian Football from September 2010 to 2016, and a pricing scientist and cross pricing from June 2008 to 2010. And apart from these leadership and governance skills, he has 4 skills of senior leader and stakeholder management, team capability, growth development and management, linear constraint and programming, ML for generative technologies, LLM, SLM, VAE, GN, neural operators, etc. Advanced machine learning statistics, Python, C, C++, SQL, deep learning, ML system design, Apache Spark user, Hadoop user, AutoML, AWS, and Azure. And this is the brief biodata. And I would like to introduce the audience what he is going to talk in today's webinar. In today's 1.5 webinar, he would like to take you to the next level of engineering the AI stack of the future. So it is like this, the speed versus value. Why this session is AI system are becoming dramatically faster. Gen AI tools have lowered the barrier to entry for building AI-powered applications. We would like to deliver 2 ways of AI system that is creating impact, the speed-oriented, that AI is Gen AI, and also the value-oriented on AI and ML systems. His strengths are clear metrics, feedback loops, long-term improvement. And the core insight is speed without measurement creates fragile systems. Measurement without speed creates inertia. So for a student of mathematics, statistics, machine learning concepts, model evaluation, experimentation, systems thinking, data infra, feedback and loops. So when we go through his profile, he covers everything from mathematics to physics to commerce, economics, and in general topics also. So it's a very useful and thought-provoking session today. I will definitely, I confidently can say that you will all enjoy this session because it is very interactive and it is mostly what you call hands-on type of session. Kindly, I request all the participants to enjoy this session. With these few words, I welcome you, sir. Now the floor is open for you. And once again, on behalf of AP State of Higher Education, on behalf of our chairman from Sakya Madhumurthy Garu, I thank you profusely, and because you are also sacrificing your time maybe it is too early, maybe 5 or 6 around early in the morning, and definitely you considered this as a very important, and you sacrificed your sleep also. Thank you very much for considering us, and the floor is open for you.
Right, thank you. Thank you
Welcome.
so much, Anil garu. Thank you, everyone. Thanks for the introduction. I so firstly, let me start sharing my screen. Just want to make sure that I can do that. Uh, 1 second. I'm having tech issues. I'm really sorry about that.
I also welcome Sridhar Garu, Dr. Sridhar Garu from TCS, and now he is a State Quantum, Amravati State Quantum Head. I welcome you, sir.
Thank you, sir. And
Thank you, sir.
welcome to
Thank
this
you for
session.
joining,
Yeah, good morning, everyone.
Anil garu, is there any setting where I need to change for me to share
Otherwise, sir, you
content?
can. I think your co-host. You are the presenter.
Okay.
Share it again, sir. Otherwise, share it again.
Yes, let me do that. Ah, can I think I've rejoined. Can you all hear me okay now?
Yeah. You can share now, sir.
Okay, thank you. Thank you so much. Sorry about that. For some reason, it just kicked me out completely. Okay, can everyone see my screen?
So now it is okay. It is visible.
Okay, cool. All right. Firstly, sorry about all of this. My name is Harsha, as Dr. Anil Garu has said. I've been sort of been in academia for a good chunk of my life in postgraduate degree from 2008, and then have been working in some capacity, getting involved in machine learning or data science or whatever you want to call it nowadays, for the past 16, 17 years now. Not going to spend any more time on that. Yes. So let's see what am I trying to actually convey here. So the main thing that I wanted to go back is, let me go to the first one. So typically when I left university and when I finished my college, I had a lot of decent fundamentals, especially in the areas of, say, for example, coding or maths or statistics or some kind of applied physics or theoretical physics, right? Now, most of us, and I am an electrical engineer by background, as you can see. So, um, and the thing that you would always find when you're actually finishing your undergraduate degree and then moving on to a graduate degree or a job is the gap of what we need to learn as theory versus what we need to apply when it comes to the real application of sort of technologies, whether it is machine learning or AI or civil engineering, structural engineering, material science, biosciences, and all of the disciplines. The barrier is quite high. So usually students who leave the university, they do feel quite overwhelmed in the first few years, simply because it's a lot to take in. Now, I'm not going to focus on everything. The point of it is just to look at how we can engineer. And when I say engineer here, we're talking about digital engineering. In the sense, we're talking about building software and digital solutions. But what I wanted to touch upon is, because we have the word AI in here, the whole point of it is, how do we apply AI to solve business problems? Or how do we apply AI to actually solve problems in such a way that actually adds value, in sense of whether it cuts innovation time, it reduces costs, or it gives you revenue uplifts, any of those combination of it. With that said, if I go to the next one. Now, if you look at the last maybe 3 years, AI or machine learning, it has been different in the last years. But the whole idea and the technologies behind AI and machine learning, they have been in the making. They were actually stewing for, I would say, the maybe 60, 70 years, because most of the mathematics, most of the statistics, and the computer science concepts that are being used to accelerate the development of generative AI models or building of any machine learning models, they are all they have been works for the past 40, 50 years. And it all starts with having a really strong foundation, whether it is in mathematics or physics or any of the STEM sort of subjects. Now, but what has changed in the last 3 years? So in the last 3 years, now, even though AI and machine learning have been around for a while, the popularity of things like ChatGPT have basically made AI almost like a word that everyone would sort of say in their own, even if you're not a technical person, you actually sort of broadly know what AI can do. Maybe not the specifics, maybe you have your own biases, or maybe you're more afraid of certain aspects of how AI would feel and do things differently to human beings. But there have been a lot of shifts. I would say we can bracket them into three sort of buckets. The very first thing is that the barrier to entry has gone down drastically. Now, what do I mean by barrier to entry? So barrier to entry, as in, if someone wants to build so there's 2 points, two things, right? If someone wants to build AI or machine learning versus someone wanting to use AI and machine learning. Now, the barrier to entry to using AI and machine learning has gone drastically down because of the availability of all of the generative AI models that we have. Almost all of them are free. Now, the barrier to even create new AI and machine learning models has also gone down drastically. Now, it's not at the same pace as the end users, but it has gone down. What it has meant is the time to prototype. Now, I'm putting it in hours here, but it's not really hours. Previously, it used to take days and weeks. And what I mean by a prototype is you have a concept or you have a hypothesis that you want to sort of prove or disprove. You go through some kind of a very broad wireframe to say, okay, if I have to solve this problem and I have these types of data sets available, how do I actually fit a technology to the technology solution to a problem which is more business oriented? Now, please to take days to weeks based on the complexity of the problem. Now, I would say it can take based on how you're actually prompting your large language model. And I'm going to say your large language model, because every time you interact with the same large language model, along with teaching it, uh, along with teaching the community to sort of use what you're actually interacting it with, you yourself are actually creating your own digital clone. So in some form or fashion, we are basically creating a digital twins in this world. So as a result of it, the time to prototype is very, very short. Because the large language model itself has been trained on, say, 40-50% of the internet, which means it knows a lot more than a human mind is able to grasp at a single point of time. But it also makes it easier because you're not constrained by different types of digital disciplines. So you can ask it to make a completely professional kind of an application. Ask it to write it in, say, a JavaScript or React.js. I mean, any sort of the technology stacks that you have, like the front end stuff. You can ask it to craft what the back end system would look like. You can actually say what kind of analytics tools you want it to build, and you have to monitor every step. You have to monitor every line of code that it produces, and you have to do a lot of quality assurance and quality check. But if you're talking about prototype, the time has drastically down. So if a senior leader, when they used to come before, it used to take us maybe a week or two based on how much data is available to actually say whether an idea has any legs. But now you can do it in minutes. The other thing which has actually shifted quite a lot is previously it used to be only text-based interactions, or the generative AI models would probably generate only text. But in the last, I would say 2 to 3 years, you have multimodal interaction, as well as you have tools that can actually produce different modes of output as well. Now, the quality of those outputs obviously is iterative. As time progresses, you actually get a lot better. Was there any question?
No, sir. Accidentally they unmuted. You can proceed. I request please mute yourself.
Thank you. So I'll continue with that. But what does it actually mean? So when we talk about engineering is quite different to actually building any kind of a machine learning or AI solution in a hypothetical sort of a lab. So you can build a lot of very cool stuff on your laptop. You can try and use some sort of a public cloud services to do that. But end of the day, you have to engineer it in such a way that it is robust enough to withstand any kind of real user challenges. Now, just because the barrier to entry has drastically gone down, it doesn't mean that it's going to produce, or the standards are quite low. All it means is, as people who are using the technology, we need to be doing a lot more checking. Now, if you try to produce some outputs which are very, very fast in the real world, they can still be wrong, because that's the whole nature of real world, that it's quite unpredictable. And hence, you might continue to see a consistent theme. This is based on my experience and the people I've sort of maybe interacted with in the last 17 years. Anyone who sort of focuses on the core subjects or the core concepts, whether they are in statistics, whether they are in mathematics, whether they are in terms of how we actually measure. Like measurement is again some part of causality and statistics there. And you'll keep hearing me say that maths is very important. Physics to some degree is very important, not necessarily in this context. You need to understand and pick a coding language of your choice, and then you don't need to become master of it simply because you have enough generative AI tools to actually generate the code. What you need to be good at is actually checking the code very, very thoroughly, and that does take time. And most importantly, the key thing to actually solving any problem, it doesn't really matter whether it is a digital problem, whether it is a physical problem, if it's an engineering problem, is to be obsessed with the problem and not the solution. So if just because you have a very, very cool tech, like you have a cool technologies like say a new kind of a variational autoencoder which has 5 layers in it, and each layer has almost like a unit kind of an architecture, and it does this amazing job of reproducing and generating real high quality images of, say, for example, um, the actual physical clouds that cover the surface of the earth, say for example, or certain parts or certain if you take satellite imagery and you process it through it, you actually have a kind of a 3D image, and you say, okay, I have this really kick-ass model which actually does all of that. Now it would actually be very useless if there isn't a business context to it, in the sense if the model is actually producing insight and output, which as a person who needs to use it cannot use it because it's too difficult or it's too far away from reality, all of the cool stuff is really not useful. So you should always be passionate about a problem. Think about how you can actually solve the problem instead of trying to throw technology or tech solutions at the problem. Now, I'll speak about in the end about problem abstraction, because I think that's one of the fundamental things that I think I have learned over the past all of my time, that is probably the key differentiator for you to be successful. Now, there's if you think about it, there's like 4 or 5 different themes here. So we might not have enough time to go through all of this, but I'll try. I can share this, and I have like 2 prompt flows which I wanted to share, show if possible in something like a ChatGPT or Gemini, so that everyone can use it. Because I usually use GitHub Copilot agent mode for doing a lot of the coding off late. But I just wanted to show, okay, what are the kind of prompts that you need to give to produce something which is very powerful. So after the session, I'll share it with Anil Garu, and then he can post it on the web or share it with you guys. But broadly, we have 4 to 5 different themes. So you have the mental model. So you have speed and value. So I'm going to, when I say speed, most of the time I'm talking about the new generative AI tools, and value, most of the time I'm talking about the traditional machine learning systems. Then just a brief introduction, not an introduction, just a brief overview of how generative AI systems actually give us the speed. Then you have the machine learning side of it. And then I'll talk very, very briefly about what you may have heard already in the news, or if you read technology articles, that people are talking quite a lot about AI agents. Now, agents are not new. They have been in the business, but previously they used to be mostly rules-based. Now the AI bit of the AI agents is primarily about making decisions on the fly based on information that they have not seen, or it is unknown to the actual agent from the past. And they're also talking about things being autonomous and then making actual key infrastructure or business and end user affecting decisions. So it's quite impactful or scary based on how you think about it. And then you have different types of infrastructure, like whether it is locally if you're doing it in on your laptop, or if you're actually going and putting it on a public cloud, which is like Amazon Web Services or Google Cloud, or Azure, or anything like Oracle Cloud. You have so many of them. And then If you get your hands on like a high performance computer, high performance computing systems are basically they're CPU farms and GPU farms. So most big companies which actually have some kind of a research and science division, they usually have a farm. Like most universities will have some form of it or access to them because they're quite expensive to run and they're quite expensive to build. But if you do have access to it, you can do some really cool stuff. Okay. Now, speed first system. So speed doesn't necessarily mean it always gives you the fastest value. There is a general misconception that if the thing is really smart, which is the system here, and it can do things in a very fast manner, it is going to give you a lot of value because it's a very intelligent being and it can actually do things very quickly. It doesn't necessarily mean that because a fundamental thing that we need to remember is when we talk about value, value has different types of themes to it or parameters to it. It could be cost saving because if you implement this particular business workflow, instead of doing it manually, if you actually do it using machine learning or a digital system, you might reduce the cost that you bear. That's one way to look at it. There might be other things of saying if I sell this product at a different price than what I was doing before, and this particular new price has been impacted by the AI and machine learning, you can actually start measuring, saying if I was selling it for 150 rupees, now I can sell it for 155, and then I'm selling say 1 lakh units of it, then you're immediately making 5 lakh rupees in it, right? And you haven't done anything. You haven't changed the product. You haven't changed any packaging. You haven't changed anything, but you're still making more money. But how can you justify making that is a different area. Now, generative AI systems, they obviously optimize time. The typical use cases that they try to address are more about productivity and automation. They have a very good UI, like it's like a chat or a co-pilot experience. If most of almost everyone on the call might have used some form of it. It's very easy. It's very intuitive. There isn't any bells and whistles. It's very straightforward. Now, the issue with those systems, as it is with even machine learning or other systems, is that these systems can actually give you quite a lot of confident answers, which are wrong. In most instances, when we talk about the types of use cases with generative AI, you have to look for a real proof of impact unless you're actually designing the whole experiment or the whole product from the beginning. Now, if I switch on to the machine learning side of it, it usually optimizes for decision quality. In the sense, you can actually you define what metric you're trying to predict or optimize against, and it is a lot more quantitative in nature. So you can do a lot more, and you can be the quality that you get from making those decisions is quite high. You define and implement really robust measurement and learning loops. You can trust it. Um, you can sort of trust it because it doesn't try to give you something it hasn't seen, but whatever it gives you, it can give you with a level of confidence, and you can design those systems. But the biggest issue or the biggest blocker for this is building and implementing a production ready machine learning system is a very slow iteration. It takes time. You need to do a lot of experiments. You need to make sure that they have the right kind of a measurement framework around it. They are heavily reliant on decent quality data, which means you need to spend quite a good amount of time and money on it. So there are trade-offs as one would expect. Okay, the next bit of it is if we have to basically combine both of them, I am going to put the machine learning and experimentation side on the left and the generative AI and agents on the right. So if we talk about a value loop, you start with your hypothesis, and I'll talk about general systems. So even though that this particular topic that I've chosen, I've deliberately kept it away from talking about machine learning AI concepts because it's already there in a lot of textbooks. You looking at the previous webinars, I think some of them have covered it, and it's more academic in nature. I wanted to bring the practical, real life flavor to this. So when you're actually trying to implement, when you're trying to implement a machine learning system or any sort of a digital system, the first thing that you need to do is you need to have this cycle of you make a hypothesis. So hypothesis, what does it look like? It looks like if I'm selling a Coca-Cola bottle for say 12 rupees, my hypothesis is I think I can sell this Coca-Cola bottle at 15 rupees or 14.50. Uh, when when we basically make that hypothesis, the rest of the experiment is basically trying to either prove or disprove that. How do we do it? We then go into a phase of experiment. Now, this experiment might be, I look at all of the historical sales. In all the historical sales based on the different areas of say, Andhra or Telangana or anywhere in India, I see that some people are able to pay more than the 12 rupees. And I'm trying to figure out, okay, what is the right price I should be offering. Now, the example I've taken is very, very bad because I don't think you can sell them that way. This works. The example that here that works is more around dynamic pricing. So, which is what you will actually see quite a lot in Instacart or any of the other services. So you don't get the same price for the services that you get based on just because two people are signing up at the same time. They might be under the illusion that they get the same price, but it doesn't necessarily mean that they get the same price. So just have to compare notes. So the whole point of the machine learning experimentation is you make a hypothesis, you make certain assumptions about the problem that you're trying to solve and an approach that you want to take. You experiment with those ideas using some kind of machine learning or AI or any kind of a technology solution. You don't stop there. Just because you do an experiment doesn't mean it's successful. You define your metrics of measurement or success all the way in the beginning when you're creating a hypothesis. So you have to actually define saying this particular increase in price, I'm going to justify it if during an experimentation phase, I'm able to not lose any of my customers, but I'm still able to make say 1% more than what I did before. So it's those kinds of very clear metrics which are business aligned that you need to optimize against. You measure the impact of the decisions that you're making. You learn, in a sense, in a systematic way, not like manually human beings learning. You build in a learning feedback loop, which always again goes back, whether it goes back into an experiment phase, whether it goes back into the measurement phase or the hypothesis phase, we don't know. But you need to build those systems in an automatic fashion. Now, on the speed loop, you always start with a prompt, you generate, and then immediately act. There's basically we're not sort of looking for long-term things. One of the things which I really like about the speed loop in the generative AI bit, which I converted into a machine learning thing on a day-to-day basis, is the current problem that I'm working on. It is a scientifically challenging problem. When I say scientifically challenging, I'm trying to process 1.6 terabytes of 3D imagery data through a bespoke machine learning model that myself and my team have built. And there is a specific business problem that we're trying to address. Now, given the complexity of the actual data pipelines and the insight pipelines that we have, I vibe code a lot. Now, vibe coding is basically saying, okay, I have a lot of prompts. I'll take the prompts and put it in some kind of a large language model, and I'll look at what it generates. Now, previously, I used to spend probably looking at code and sort of experimenting. If I would say I spend 4 hours a day. Now I probably spend the same 4 hours and more checking the code that I vibe code using any of the large language model tool. So it doesn't produce a high quality thing out of the box. You need to check it, you need to double check it, you need to test it, there's a lot of things that goes on. But the reason I'm mentioning that is if these large language models were not present, I can guarantee that the amount of code and the kind of research breakthroughs that myself and my team, specifically, I'm just talking a very small, very small problem in the whole ecosystem of these things. I can guarantee it would have taken us at least an year. Now, it doesn't take us an year. It actually, we were able to do all of that within 2 to 3 months, and we can iteratively, very quickly build new extensions to it so that it actually solves multiple problems. So the rule of thumb is use GenAI to act fast, get what you need from it. If it is like if the problem requires building an application of machine learning model, then you can use generative AI to act fast and then actually experiment on it. Now, I'm not going to go through this because I think I've just spoken about most of the things here, but there are different types of approaches, like industry standard approaches, which people use when they're trying to manage like a data science life cycle. So if building machine learning AI models and things like that. So the one here is called is from Microsoft, called Team Data Science Life Cycle Process. I mean, process life cycle. It's a very commonsensical thing. If you work in these teams, maybe even for like a couple of months, you'll start seeing that, okay, it's a very similar pattern. So you actually have certain common themes. You would try to do things in a certain way so that you can actually learn and relearn and scale fast. So not going to talk about this one. We can do it afterwards. Now, generative AI. So when we talk about the Gen AI and what actually is inside at a very high level, right? So we are talking about large language model and VLM is a vision language model. But the interface or the window into any of these intelligence is a chat or chat UI. Now, in most instances, the things that we're trying to solve are in industry. I have a farm of EV chargers. Now, in the EV chargers, when they work, they are good. When they don't work, people obviously call up or use a mobile app to lodge a complaint. Now, I need to basically be on top of solving any of the problems that I get in a very timely fashion. So the very first thing I need to do is have some way of going through all of the complaints and telling me what is a common theme. Is there a regional bias in the sense, those EV chargers which are on that highway seem to be breaking down more often than the chargers that we see inside the outer ring road of a city. Now, those are the kind of real life problems. No one is actually going to tell us to say, build me a large language model. Sorry, build me a AI system which is using a large language model to go through all of this data and come up with a solution and it has these characteristics. No one tells us that. In industry, they'll actually talk about their business goals or their objectives. They'll basically say, I want to reduce my complaints by 5%. I can't have this many complaints. I actually want to have 0 complaints, but I know it's not going to happen. So let's take it incrementally. I want to start by reducing 5%. And the question they ask is, how do I do that? Now, this is a kind of interface. These are kind of questions that they'll ask. Now, if you put it in the generative AI system, it can go through all of the historical complaints in a very robust manner. It can come up with some kind of a summarized information, as we all do using any of the large language models that we have access to right now. But the top issues when we are doing it in this way is it does introduce bugs. There could be an inherent latency. Now, when we talk about orchestration, it doesn't matter what problem you're trying to solve, whether you're trying to generate code to do a machine learning model, you're generating code to build a UI or a backend, or you're actually using the GenAI system to find a new research breakthrough. Everything starts with having the right kind of prompts. And I'm not talking about prompt engineering because that's a different thing. these systems are so intelligent and so powerful, but they can't read what you want it to do. So they can only respond to what we actually ask it, which means it depends on how you're asking the question and how you're actually orchestrating the different types of questions or prompts and how you're prompting the whole system to get the solution that you want. Now, in all of these things, there are certain other concepts called memory. So memory, think of it as the number of tokens that the large language model uses. It basically, it's almost like a context window. So if two human beings are actually talking, say for 2 to 3 hours, we will have a good enough context to say, okay, what did we speak in the beginning? And we can trace it back. And sort of, if someone else asks a question saying, oh, the thing that you said 80 minutes ago, I want to clarify that. If they can easily go back and clarify it, or maybe we might take a second to recall what it is. In the context of a large language model, because it's not made for a one individual, but you can make it work for one individual. There are these concepts of memory as well. Now, in the orchestration, there are other things. I mean, the most important thing I would say, especially if any corporate or any enterprise or even non-corporates like us, we need to be worried about or thinking about is what safety guardrails and what policies have been actually implemented in the system that we are using. In most instances, if a generative AI system in enterprise editions, if it says that it has no option, it doesn't give, if it doesn't give any option to the enterprise to say, I don't want you to use my data and information to train yourself, that model and that approach doesn't scale. It won't be a successful business simply because that's not how enterprises want to work. Most of the data that it works with is actually very company sensitive. Like, we want to use the best systems to actually deal with the complex problems. Complex problems usually arise with quite sensitive stakeholders and data sets. So you need to be aware of those policies and guardrails when you're actually building a generative AI system or any sort of AI system. Now, I know it's a very high level thing. I would say very quickly, what does GenAI do very well? It does rapid prototyping. I mean, all of these things, I think in some form or fashion we've seen in the past. Off late, the reasoning approach is quite good because it can actually tell you why it's thinking or why it's producing what it is producing. I absolutely love the developer acceleration. Developer meaning like a software engineer or anyone, actually. That's the barrier has actually gone down. That if someone wants to create templates or initial frameworks and then sort of constantly refactor with it, you can actually use the same coding agent to help you go through the entire process. And you can literally handhold it, or it can handhold you based on how you're using it. Now, again, we've heard a lot of these, but I wanted to talk about a couple of them. So data staleness is quite important. Now, in most instances, any of the generative AI models, when you build it yourself, you basically have a great idea and you're trying to throw technology at it, and you actually throw it and you solve some kind of a problem. But the main issue comes how you design and architect the core systems which feed information and data into your model or into your system. Now, when data gets stale, the output or the insight it produces is very incorrect, or it is biased, or it is uninformed, and you cannot have that. Now, you can probably have that in certain instances, but you probably cannot have that in most instances when critical um, uh, decisions are being made. Now, where does this stack? So we have different layers, and I don't know if you would be exposed to these kinds of things, but my fundamental belief, because I was an electrical engineer, then I got sucked into maths, so I did quite a lot of that. Then I worked in as a pricing scientist, applying linear programming and optimization techniques quite a lot. Then I've done quite a lot around retail analytics, and I've done quite a lot of work across different companies, building recommendation engines. I mean, there's a bunch of stuff that I've done. And the reason I'm mentioning that is the key thing I would say is which might come as a bit of a surprise, not a surprise, but maybe uh, a shock or a rude awakening, is um, in this world where we have generative AI tools, uh, the ability to write really good code becomes lot more important, but at the same time, the generative AI tools themselves can produce good quality code. So the people who would probably the kinds of roles that we would see, are more around um, doing bespoke things, bespoke software solutions, which means that irrespective of what the question, what kind of a problem is, the human being who's actually doing it, whether they are a junior developer or a senior developer, they need to understand the problem really well, and it all comes back to what kind of prompts that you build, what tools do you actually want to use for it, and what tools do you want in the prompts to be used to build the end solution, and things like that, right? Okay, so this, just gonna go to the next one. Yes. Okay, I'll spend maybe a minute on this. Now, if you go now, we've spoken about the generative AI side of it a little bit. Now, if you look at the machine learning side of it, so when I say machine learning, it's traditional machine learning. What was all deemed and called as AI before generative AI is the thing where people go back and build models, build neural networks or build regression models or tree models, any of that. Now, uh, machine learning models, like, because that's what I have sort of worked on for the past 17 years, and even in my PhD, that was very similar to it. They create durable impact. Now, simply because you can, from the beginning, you actually have to be very clear on what your metrics of success are, and then you agree them with your stakeholder, whoever the stakeholder is. And then it basically says it's very easy for you to see if this output to the solution is actually been successful or not, because you can measure it against quantifiable metrics. It Now the thing about turning intuition into evidence, I do believe it is the case, but it does take some time. So we do have to address that. Now, what are good examples of this? So a typical machine learning model, it has like millions and millions of questions for it, but I just wanted to pick something which I find useful. You might be creating an online content or an advertisement, doesn't really matter, and you basically want people to click on it and do it, and then end of it maybe purchase the product. Now, I'm not talking about creating clickbaits. That's not what I'm talking about. What I'm talking about is if you have a genuine sort of advert or content, uh, how do you want to place it in such a way, and who do you want to place it in front of, right? So if you go into YouTube, which I think every one of us or most of us use, YouTube uses a recommendation algorithm in the back. So the recommendation system is not a long memory thing. It's a very kind of a short memory thing. It either looks at your subscriptions or it looks at what types of videos you've seen. Now, again, it's very easy to just say, okay, what types of videos? But when you actually break it down into data, you have to literally engineer features which capture the type of movies or type of content that people are watching. So you'll have like hundreds of thousands or 100,000s of features for each one of those videos. And then there is a machine learning model in the back which analyzes all of that and says, Harsha and Anil Garu and a bunch of others, they belong to this group. So these types of content should be surfaced to them. And others, they belong to a different area. So they need to be served different types of advertisement. So there's a lot of machine learning that goes on in our day-to-day life, which hopefully we are aware of. But if you're not, that's one of the examples. So the questions would be, okay, I want to have more viewers to click so that they click on the adverts on YouTube. Or you might just say, as I was giving an example, as a supermarket store, say More or something, they usually get additional money to promote a particular product from the actual manufacturer. And when they're trying to do that, they need to figure out where exactly to place, how much do they sell it for, is it on a promotion, is it not on a promotion? They get paid the money, the incremental money, if they're actually pushing a new product. So all of these things happen. And then there is a thing about where do you exactly place the product is one part of it. How much do you charge for it? That's another part of it. And if you're doing it on an online setting, you can have different approaches to it. So again, this is another problem that you can solve, or people have solved using machine learning. The other thing that we do on a very daily basis is especially in any region or a country where they have credit scores. One of the things that people typically do is if you want to build a home or buy a car or something else, you want you go to the bank or a financial institution and you apply for a loan. Now, when you apply for the loan, they do ask for a bunch of information. Now, all of that information, in some form or fashion, in like I said, in countries where there is a credit score of sorts, it goes into a very simple or complex machine learning model, which gives the actual manager who's sort of approving the loan, saying whether they should be approved for a loan or not. Now, it could be a number, or it could be a number between 0 and 1. 1 meaning, yeah, they will definitely repay the loan in the amount of time that they're actually taking the loan for. So feel free and feel confident in giving them at the amount that they need. Or they can be on the lower side of the zeros, which basically says, oh, don't give them the loan because I don't think they have the kind of financial rigor or the assets or anything. I mean, it could be the amount of money that they're asking. Now, these types of models, especially in the West, have been in use for a very long time. I don't think people realize it fully, but yeah, they have been in there for a very long time. Now, when people say AI, how is it impacting us? All of these things are already done. So there are ways to do that. There are models which big banks use to identify any customer who might actually default, in the sense they or overdraw, like overdraft. If say for example you have a credit card or a debit card that you have and you use all the time, sometimes the banks allow you to actually go maybe 0.5% or like maybe 500 or 1,000 pounds or dollars more below your actual balance in the account, because they expect you to repay it back within the day. Now, the issue is a lot of times people do use it as a means of getting by, which means that those types of people, if they get more loans, it's not good for them and for the bank to actually have more and more debt. So you have to figure out other products that are suitable for them. So those types of things are also done using machine learning. So I think I'm talking too much about one particular use case. Now, when we talk about a machine learning product in production, it's not a single model. Usually, you go through multiple stages. You have a stage of offline evaluation. What it means is you're gonna build a model. You're gonna do a proof of concept of sorts. You will actually do some kind of back testing, in the sense you define your metrics, and in the metrics you go back and um, see how your model is working on things that it has seen in the past. Then you sort of deploy it onto an online environment, and then you start measuring the impact based on real-time interactions with end users. Once you do the experiment and you feel like it is actually giving the right kind of uplift, you then go into the deployment stage. The deployment stage being where you actually start scaling. When you're doing an experiment, it doesn't make sense to deploy it to everyone across the world or even across your user or consumer world. So you want to do it in very small chunks. Once you feel confident that what you're doing is working on the small chunks, then you go into the deployment. But it doesn't end there. So just because you have shipped a product, especially a machine learning or an AI product, it doesn't mean that your job ends there. You obviously have to constantly monitor if the underlying data has changed and how much is it drifting, which is moving away from what it has been trained on. A good example again is around if I take a financial institution example, good example of it is who should be getting a loan. Now, the demographics of people living and applying for loans has been changing quite a lot in the last 30, 40 years with the types of new kinds of jobs and everything else. Now, as a result, if someone was actually had built a model which was suitable for 1980s, if you apply the model in 1990s, it won't be useful because the people who have applied are applying for loans. They have different kinds of salaries now. They have different skin colors. They belong to a different background. They come from different areas of the world, or even the country, to apply for it. So you can't really take your existing model and expect it to work. Existing model expected to work on newer data because it has not been retrained and recalibrated. So that's where monitoring and drift comes in, which means you build a automated system which looks for certain characteristics, especially in the context of a machine learning or an AI system. And then you monitor the drift, and based on the drift, you go back and retune the parameters that you have to make sure that it actually fits what you need to do now. Now, Google has done quite a lot of interesting work on that side. They have published a paper many, many years ago called Google ML Test Scores, which lays out a whole chunk of metrics that most digital systems or digital products that they believe should be using and deploying to measure whether they're ready for machine learning and AI. So measurement is very, 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 very important. So without measurement, we can't really do much. So if you talk about offline metrics, many of the times what we have are different types of accuracy measures. I don't know, but based on the discipline that you're actually studying, you may have heard about other things, but accuracy is very, very common enough to say. If you're building a model and it's predicting something, you actually want to measure how far away or how close it is to what it was supposed to predict, and you can use it to feedback and improve the system, just like how human beings work. Now you can have different types of things. When you talk about offline, you also have to take into account what is the latency and the cost per request. And there are things like regression tests for prompts. So if you're actually using prompts, how do you make sure that they're robust enough? And if you switch it into an online system, the key things that you actually want to measure is you don't want to lose any existing users, which means you don't want them to churn. If you're building and you ideally want to have an increase in the conversion rate as in you're presenting a product to someone or presenting some services and you want them to buy that product or pay for the product, which means it's a conversion thing. So ideally you don't want to lose any customers. You want to increase the amount of money that you make. You want to save as much money and time as possible. And then you also want to have a high quality kick-ass service, which is the whole thing of quality outcomes. Now, all of these things can't be done at the same time. It will be very, very challenging to actually build a single digital system which is intelligent enough to do all four of them at the same time. So you pick and choose and you do different types, different flavors for it. Okay, so when Anil Garu was actually talking about giving a little bit of a background earlier about me, I think you would have heard some numbers. The numbers are not important. The thing that is very important is anything that you say that you've generated a value um, against, that number should be robust enough to sort of be questioned and challenged, and you should have a very realistic and rational and quantifiable response to it, which brings to basically the whole question of a measurement framework. So without a proper measurement framework, it's very, very difficult to actually convince a stakeholder to pay to invest maybe $5-10 million on building a product. It's very, very difficult to actually not just convince the stakeholders, but it's very difficult for yourself to actually know whether this product is giving the value. Now, there's bunch of measurement frameworks, and these things typically apply mostly for online systems and not like physical systems. But even if you take it in an online context, there are things like A/B testing, and you have ABC testing. You have different types of testing. So A/B testing basically answers a question: by taking this action, did it actually improve any outcomes? It's a very generic question, so you fill in the blanks with the exact question that you have, right? So A and B, meaning that you define a control set, which is an A, you take a separate set called a treatment, which is a B. The control system, as the word says, controlled, you're not introducing anything new. So you're doing business as usual. Whatever we have from the past, we just currently keep doing it. That defines some of your baseline metrics. So that says, okay, if I'm not doing any different and I'm trying to sell the same product, okay, these are my sales numbers, right? So that's an example. Now, the treatment group is what is getting the actual treatment. So that's who, those are the people who are getting the medicine. Those are the people who are getting a different action to what, an action which is different to today. And you'll have the exact same metric definitions. You'll have to have the exact same way of measuring it, because that's when it becomes comparable. And then when you do these things and you say, I'm going to observe both the group A and group B for 6 months and see how things change. You need to give it enough time for things to take shape, like, and the metrics to make sense. And end of the day, end of that 3 months or 6 months, you say, okay, in the control group, I had a 10% click-through rate. On the other side, I had 12.5% click-through rate. And both of them had very similar number of user sort of interactions, which means that the treatment I'm giving seems to be making more sense or more business sense. Now, when we do this, what are the different types of issues that we might face, especially in experimentation? Data quality is very important. I mean, yeah, all of these things are very, very commonsensical, but I just wanted to mention one bit. So data is absolutely very important. The way you define your A/B groups is very, very important. The way you're actually implementing how users are directed to one kind of an Instamart page to a different kind of an Instamart page, that's very, very important as well. You can't have any bias in that, or if you have a bias, you have to bake that bias into your calculations. So many, many more things. The key skill that is required for any software engineers, especially, or even not just software engineers, any of the scientists or even other kinds of engineers, is when you're designing an experiment, you also have to design the metrics of success along with it. And then you have to constantly measure. If you're not measuring, you're not definitely improving, because you don't know what you're improving. Okay, I'll quickly walk through a few examples from my own for what I've done. So the first example is around price optimization. So price optimization can work where the market or the regulation allows for doing something called as a dynamic pricing. So dynamic pricing literally says that you can charge a different price for the same product to a different customer. Now, it sounds very, very nefarious. It doesn't, typically people don't try to do that in a B2C setting, in the sense like to end users like us. They typically, this applies, and the work that I've done mostly applies into the business to business decisions. Like if a manufacturer is, if a medical supplies manufacturer or paper manufacturer is manufacturing a bunch of kitchen towels or toilet rolls or hand tissues or paper forks and spoons. Those things are typically bought by other businesses. So it could be a cafe, it could be Starbucks, it could be anyone, right? I mean, you can name anyone. So a business buys it from another business. Now, if one business is buying a lot of product from you, you would probably be thinking, okay, I definitely want to retain them as a lifelong customer. So, what do you say this? Yeah, you definitely want to retain them as a lifelong customer, which means that I need to do a lot more. I need to I can give them a discount. I can actually charge them lower than other people. And maybe there are other businesses which actually come in once in a while, and then immediately they don't need to be given the best price. They probably are to be given whatever the retail price is, the wholesale price. That's where those concepts come in. Now, the whole idea here was how do you decide the right price point for a customer? You go through a big bunch of clarification of the business asks. You identify what sort of variables and features can help you predict a pricing behavior. You then create a form of a segmentation because it is in a B2B setting. You can actually create different types of groups of customers with similar purchasing behavior. You build a system which does a optimization against it. So based on these groups, you actually have an understanding of what a group should look like and how much they have been paying. And then you can define a very simple optimization routine versus a very complex one to figure out what exactly they need to pay. And then end of it, you implement it and see if you can realize value. In this particular example, the ROI was around 115 to 120 sort of basis points in the first year. Now, the next thing around retail analytics is very, very interesting. If anyone is going into that at some point of time, again, be obsessed with the problem. The technology and the team and everything else usually gets sorted fairly easily. Now, the question all the time is, so there's a bunch of these problems we're trying to solve. One of the things, I think we have questions. Are we taking questions now or in the end? I think. Sorry, I think it is gone now. Okay, so what are we talking? Yeah. So retail analytics, again, there's a few more things I want to cover, but I'll at a high level, what we can talk about is if we are actually trying to, so one of the companies that I worked for was called Experian Footfall. So that company, what it does is it has people counting machines, which are cameras, which are installed in most of the stores in the UK and Europe. So they are installed in the entrance of the store. When it is an entrance of the store, what it does is it looks at how people are crossing a particular line, and then says if people have crossed this way, they count it as in. If they've crossed the other way, they count it as out. Very simply. I mean, there's a lot more different variations of those cameras. So when we were working with them, when I was working for that company, the key thing that we were trying to figure out is a couple of them. How do we identify hardware anomalies in footfall detection to free up? So what does it mean is based on the different types of camera technologies, sometimes some cameras will pick up shadows as additional people, which is absolutely wrong because it inflates the number of people who are visiting you on an automated fashion. And sometimes in extreme heat, there's like vapors that are coming from the ground because of moisture. And as time progresses, even those things get, sometimes they're double counted, sometimes not counted at all because it just feels very blurred. And the other problem that we're trying to solve was you have different kind of Wi-Fi points, then they're not really actually giving you Wi-Fi connection to your mobile phones, but they have these systems installed in most of the shopping centers that we have in the world, and they're constantly, what they're doing is they're sending a Wi-Fi signal. As most of the phones that we have are smartphones, so smartphones being smart, they try to always, even though they're connected to a Wi-Fi that we trust, they constantly keep communicating to any other Wi-Fi signal that we have. The moment you actually do that, what it gives is those Wi-Fi points, they have an ability to know how you're moving within that shopping center. Which means that that particular information is absolutely very, very important so that if they can sell it to other sort of stores which are already there in this in the shopping mall, to say, okay, these groups of people, these types of people, when they enter from the parking lot and walk this way, they're most likely to go to a Starbucks or they're most likely to go to something else. And these kinds of information could be very, very useful if you're actually trying to design the layout of your store or if you're trying to redesign the layout of your, say, shopping mall. So the different types of problems that you're trying to solve are very, very varied, especially here. Now, in most of the time, Python wasn't there at the time. Rather, it was there, but we couldn't use it because we had to deploy it into a data center, which was completely impossible to get the approval for Python for. So these are some of the practical considerations. So we ended up using something called C# and then obviously SQL and Excel, and there's different types of methods that we used there. Sorry. I think this is the last exam. Yeah, this is in terms of examples, this is the last one. So the other thing that I would say is there's for online retailing, searching and intelligent searching is very, very important. In the sense that if someone is searching for a product online, how do you make sure that the right products are surfaced to the right customer? Now, that basically goes to the whole point of the example that you were talking about earlier around YouTube and what sort of videos it sort of surfaces when you search for something, right? So this is exactly that. So we were doing this particular project for a online grocery retailer. And we had to build this system, which is a recommendation system based on a method called collaborative filtering, which is an item-based collaborative filtering with implicit feedback, no explicit feedback here. And then different types of search technologies were explored, finally landed on Elasticsearch. And the other sort of tech stack would be we're using Amazon Web Services for it, Python was being used, and we're using Spark for distributed computing as well. Now, I can talk at length about what the actual system is and what the stats and maths are in the back, because as I think I mentioned in the beginning, if you're actually building any sort of a AI system or a machine learning system, please don't be just an end user in the sense importing a package and then sort of running that package or a library on the problem and expecting it to do wonders. It doesn't usually happen that way. You need to make an informed decision, which means that you need to really roll up your sleeves and understand the maths, understand the science behind it before you actually use it. If you just use it, you're not going to learn anything. You won't benefit as much. You can't really differentiate your product from anyone else's product because everyone else can do the same thing now. Now, when we did this particular project, we did see that the recommendations from the machine learning models, they were about 15% more than the existing system. Like if I do the A/B testing, we did give a higher sort of intelligent and relevant search results, which is very, very good. Okay, how do you choose the right tool for the job? Now, all the time, I'm conscious and I'm aware that I'm speaking to students as well as non-students. So for me, when I'm talking about in most of these instances, I'm talking about how do you generate value for an enterprise, like in terms of when someone chooses to get into a job, what are the different types of things. So when I say speed versus value, I'm talking about speed versus value in the context of a company. If you, as a technologist, if you think that the problem that you're looking at needs a lot of speed, sure. I think this is the area that you need to be in. Like do something very quickly, but then be aware that there are risks of doing things quickly. There's a lot of double checking, triple checking that you need to do to make sure that what you're building is relevant and is actually right and can be trusted and is safe. Now, if you need a lot of proof for what you're building, and then you don't need to be very, very fast. This is the bucket that you want to be in. Now, it's not ideal for most situations, but when you do build it, any value that you get is a lot more robust and you can rely on the numbers. So there are different types of combinations of this. I'm just talking about extremes. If you only need speed and you can say, okay, I'm okay being a little bit wrong, then you can go with GenAI. If you have to basically build your own and then you need proof of its value, then you need to get into machine learning. Sorry. Now, chatbots to agents. I think the whole idea behind a chatbot, I think it has been doing the rounds for maybe the past 7 years now. Many people have started building chatbot experiences. Now, when you go into the next step on the evolution as to how things have gone in this particular space is chatbots have now become like Copilot interfaces. A Copilot interface is the way that you actually chat with anything else. So if you're using any sort of a Copilot, whether it is a Teams Copilot or the ChatGPT version, any of that, the idea is it's still a very simple chatbot, and you're just talking to it in some form or fashion, and then it can do a bunch of specific tasks or very, very generic tasks as well. Now, a workflow agent is now what we're talking the point of this particular slide is to talk about the introduction of the lingo called AI agents into this world, right? Now, agents of some kind, like digital agents, of some kind have been in use, whether it is the physical control systems, where if you're operating, say, a nuclear reactor or a heat exchanger unit or whatever it is, those agents have been in place. They are most rules based, in the sense, if the temperature on this particular if the temperature in this particular sensor increases by 3%, and if the pressure on the other side reduces by 2%, okay, you need to create an alert. So you do something and the agent does something and it adjusts those things. Those sorts of agents frameworks have been in existence for a very, very long time. Now, presumably they were, because they were rules based, if something dynamically changes in the system, they won't be able to respond to it dynamically. So you need to recalibrate them. So that's a big pitfall. But when you talk about workflow agents, what we're trying to do is when people talk about workflow agents in the current world, they're basically saying, I have a generative AI system with, like, for example, a large language model or a vision language model or any of that. It has the intelligence and ability to absorb a lot of information at the same time, arrive at a decision which is more robust, but yet, I mean, it is a lot more intelligent than a rules-based system, but it can produce unpredictable results. But the overall idea is you are trying to figure out what tasks I can actually give it, which are low risk, so that I do not have to worry about it failing or doing a bad job. So when we talk about a workflow agent is saying, I have multiple steps in a particular task. I'm assuming that most of the tasks here are low risk, which means that if the automated agent actually does get things wrong, or the recommendation it gives might not be that great, I'm okay because there's a human in the loop who can correct that, or the actual decision cost is not that high. The next thing that you hear quite a lot of late in the news, and even in technology news, is an autonomous AI agent. Autonomous AI agent, it almost anticipates what could go wrong. It creates a plan, or it actually plans on a regular basis to say what are the actions that could go wrong. How do I want to act? It can create a plan for it ahead of time based on how you configure it, or it can actually go in real time and take the data, observe the workflow, execute the workflow, see what the output of that particular step is. If it doesn't meet its standard requirement, it's going to redo it, and doesn't need any human interaction. Now, this sounds very dangerous and ominous, but as long as you have the right kind of safeguards safeties and guardrails in whatever form, you would be okay actually deploying an autonomous agent. And the best way to do that is to build these autonomous agents which are looking at low risk activities, low risk tasks. Now, in very, 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 very broad terms, when people say agents, they're basically talking about generative AI and then some kind of policies and some kind of evaluation and tooling. Again, not going to go through this. Okay, infrastructure. I'll spend very, very quick time. I think we have like 6 minutes now. Now, there are different use cases as to why you want to deploy some or build and deploy products at locally versus non-locally. You can build and run a AI or a machine learning system locally if you want low latency, but it doesn't scale. We have privacy in the sense that data that you're working with is absolutely sensitive, so it stays on your device, doesn't leave, so there's no risk of it leaking outside. And you don't want to spend a lot of money on cloud. Now, offline on a local machine works usually when you're in the experimentation hypothesizing phase. Now, there is a case of an edge as well. So when I say local, I was talking about local development, but when you're actually deploying it, you can actually deploy it on edge devices. Edge devices meaning they could be smartphones, or they could be some kind of a like a local infrastructure units that you probably have in like big factories. So in big factories, when you have automation as well as automatic detectors of bad food versus good food, if you have things going through a lot of sensors, you need a lot of computational power. But then the amount of computations that you would do and the amount of calls you would make to that makes it infeasible in terms of latency to go to a public cloud instance. You probably want a local computational device, but local computational devices, you need to maintain them. And so each of them has trade-offs, one versus the other. But there are use cases wherein you need to develop locally and you have to deploy on the edge. And in most instances, it's around robotics, it's around industrial sensors. It would be on especially where you actually have to deploy and take a decision very quickly. So say, for example, if someone has an electric car, like a Tesla car, most of those things will have a feature of automatic driving. That automatic driving, in most, I would say most of the computation happens in the car. So the car itself is a computer. There will be instances where it has to go to a different location, fetch the insight and come back. But if it is driving at say 40 or 50 kilometers an hour, and then it suddenly sees an animal, or it suddenly sees a human being cross the road, it has to stop immediately. Like there isn't, um, there's no amount of intelligent thing insight you can get from an offline system is going to be useful there. So there are use cases, very, very specific use cases, wherein you want to develop locally and deploy on the edge. Then there is around cloud, and which is where most of the deployment happens of most digital systems in the world right now. Now, why do people go there? Very, very easy. Like it's almost like a no-brainer. You can scale elastically for inference. You can scale elastically for even for training. You can scale to different regions as you need, because any of these public clouds, they have regions across the world. You can deploy, and the kind of tooling that any of the cloud providers give you in order to monitor your digital infrastructure is absolutely great. No one can build that. No one wants to build that. So there's obviously cloud will dominate the whole deployment pattern just based on that. And also the biggest things is it is cheap, but you do have to cost it properly. You might see some latency to the users. It depends on the type of use case and the product that you're building in. And obviously, there's always considerations of security and compliance that you need to put in at any point of time. Now, HPC, like the high performance computing, it's primarily for training and scientific rigor. So maybe amongst the students, some of you might actually decide to go, or many of you might decide to go do after your undergrad, you might go into masters, or if you're in masters, you might want to do PhD. Or you want to stay in academia and do more research. In any of those instances, the usual viable option is having like a high performance computing center or access to one, wherein you can do scientific computing very, very fast. You can iterate through ideas very quickly. You're not paying anything incrementally because it's already been paid. So the reason I'm talking about all of these things is that when you're trying to design a digital solution, it's not one thing. Like having a good idea is absolutely important. Making sure that the idea, if it has a machine learning or an AI component, is measured robustly, that's very, very important. But you also have to think about scaling that particular product and taking to what's called as production. If you have to take it to production, there's a lot more engineering thought that one needs to put in, and this is basically just trying to showcase that. Now, if I have to put skills maps and what are important and what are not, I would say you need to understand anyone who's getting into the job market right now, they need to be, I wouldn't say fluent because it changes and everyone is trying to learn, but you have to be very, very comfortable using the existing generative AI tooling stack and workflow stacks to get exactly what you want. It doesn't mean that you don't know how to code. What it means is you know how to check code properly and correct it on the fly. You need to be good at systems engineering, and as you keep going up in the pyramid, uh, it says the least necessitated, but I would actually think about it as a foundational thing. Anyone who's trying to do these things should have a decent exposure to maths and statistics. If you're trying to build a machine learning model, definitely you need to be well versed with those fundamentals. You need to understand evaluation, like experimentation frameworks and monitoring, etc., etc. Now, to me, these four skills are absolutely very, very important. Like if I'm hiring or if I am interviewing someone or if I look for something in most people, irrespective of what their education background is, what discipline they are from, I would always check their math, probability, and statistics. They need to have a general understanding of how to design a system and how to monitor the systems as well. Okay, that's done. Okay, what are the different types of jobs that we might see in the future? This is one example. Traditionally, we have a coder. Now they would be called like AI systems engineer, and this is just a high level thing. So most big organizations are currently going through a phase of mapping the existing job families that they have and job titles to the newer job titles, simply because as things are changing very, very, very rapidly, and the amount of impact like generative AI tools are having, most instances, the types of skills that are required to operate in the future of work are going to be very different to what it is right now. So just brace, everyone is bracing to see what the change is. Okay, this I really hoped I had more time, but that's okay. In this particular thing, I just wanted to give you an example, like a very, very, very simple example, a simple example of how you can write good code in such a way that you can scale it. If someone's actually using Python or exposed to Python, there are things called decorators in Python, which, as the name says it, they embellish an existing function. So you can take any function, you write a decorator to a specific thing. What it does, it takes the output of any function that you're writing, it could be outputting anything, and then you sort of customize it and make sure everything is standardized. That's one use of a decorator. And this is one of very simpler things that we had done and the things that I could share outside of the company around how do you use a decorator, say, for example, to create standardized outputs. So if 10 people are writing or touching the code and they're writing different things, how do you ensure that the output is streamlined in such a way that you can log everything, for example? So just one example there. I think we've spoken about this a lot. Yeah, just wanted to spend definitely 1 minute on this. Now, the most important thing I would say, like I was mentioning in the beginning, when I transition from studying to actually working, having technical skills and really good technical skills is very, very important. But more importantly, the key differentiator would be problem abstraction. Problem abstraction meaning uh, you should be able to speak the language of your end user in the sense that you should be able to understand the problem that they're trying to solve. You should be able to put yourself in those shoes and literally say, okay, this is the problem that I'm experiencing. Now, in that problem, how do I create a solution which can actually solve it? So again, don't put a technology hat all the time. Be obsessed with the problem and the business value that you're trying to deliver. That's the second part. The other thing that I would say is answer these things to yourself. I know we can't do a live poll here. They are very simple things, right? So answer to yourself, do you know what basis functions are? Like basis functions are. Do you know what eigenvalues and eigenvectors are and how they translate into a practical setting? So think of those things in practical settings, not like theoretical textbook versions. And also think about how would you build the state of the art AI or a machine learning model for deploying onto, say, for example, a remote telescope or a space probe that the ISRO or someone is sending, right? What considerations would you actually have to make for it? It's not the lack of human intelligence that you can embed into it, but you also have to think about how big the model gets, how much heat it's going to generate, how would you provide it with the energy to actually train and make the inferences on the fly. So these are the kinds of things that you want to think about. Yes, and that's it. That was my session. I apologize. I went 5 minutes over. And if anyone has any questions, I do need to jump now. It's getting late for a next thing that I have with my family. But I can share my email with Anil Garu, and if you have any questions or anything, please get in touch. I would love to have a conversation with as many people as possible.
Thank you, sir. Thank you very much for making a very wonderful presentation. Dear participants, do you have any questions? Please, you can ask 1 or 2 questions. And I think there is one in chat, sir. What are the trends you see in the evolution of LLMs? And how do I get better at building agents and prompts? This is the one short question.
Okay, cool. So I would say the trends that I'm seeing in the evolution of LLMs is, okay, the gold standard, no, not the gold standard, the marker that everyone is driving to is the AGI bit, right? Like artificial general intelligence, wherein it will replace most of the things that we need to do on a day-to-day basis. So I get that. Now, one of the things which I would say is I would actually start thinking about, so you're talking about LLMs, like large language models. Start thinking of small language models more now. So small language models, they do not have the multi-trillion parameterizations of the large language models. The small language models have a few million or maybe a billion parameters. But small language models are very, very powerful because you can actually train them and tune them at your whim. Large language models, you can't. We don't have the energy resources like many countries. Whole combined GDP won't be enough to actually train them and maintain them. Whereas small language models, you can build them on the fly. There is a paper called Tiny Stories, which you can use if someone's interested. Just go through that, and it'll actually walk you through how to build your own a small language model, and things like that are very, very important. So I would say, what trends do I see in the evolution of LLMs? I think everyone is going towards the AGI bit. I don't think AGI is going to be as impactful. End of the day, we make the choice whether we want to engage with the AGI or not. My personal feeling is, being the kind of human beings that we are, I don't think we'll engage with it that much. So I would say LLMs for specific purposes would be the future thing. And the application of LLMs to different applications. So which is the next question there? How do I get better at building agents? So LLMs and agents are a natural synergy that happens there. LLMs and language models can easily understand most contexts and come back with cohesive insights. And if you actually add on the engine of an agent which can actually act independently, that takes it to a different level. So that's what it is. Okay, there's another question. LLM tuning, step-by-step coding to pharma, medical chip designing. Please tell about material methodology. Okay. I would say LLM tuning is, so when we talk about LLMs, there are different aspects to it. What we call as fine tuning is very, very, it's one of the most expensive things that we can do in the face of the earth, right? So large language model tuning usually means that you're actually tuning the parameters of the large language model. The number of parameters we might have, like the first version of GPT, ChatGPT, had like 1.75 trillion parameters. To train such a model, even for a day, takes the amount of energy of probably half a city of the day. So I would think, I'm assuming that it's more about, it's not really fine tuning, but maybe training or giving it some kind of a RAG background, like RAG meaning retrieval augmented generation sort of a background, and giving it a very robust knowledge base. So I would say that's where the answer might be. The thing that I think there is a research angle to it in terms of chip designing at pharma and medical. So again, Ravi Garu, the key thing would be it depends on the question or the example that you're trying to answer here. So, for example, right now I'm working on two scientific problems. One is around looking at seismic images of subsurface Earth, and another thing is to look at some kind of anaerobic digestion processes. Now, I mean, I cannot emphasize it more. I am basically not a lab scientist, so I do not know what an anaerobic process is. So I do have to understand what it is. I do understand images. I do understand signal processing, so I can probably do a little bit more in terms of seismic imaging. But in both of those things, I would say using the LLM to actually have a very, very robust interaction, spending time on the output it produces, uh, was very, very helpful for me to get used to the terminology and also the underlying problem. I will not become an expert in anaerobic digestion at all, but at least I know what parameters go into the equation that underpins everything around anaerobic digestion. I don't think I answered the question, but sorry about that. Yes, I'm going to share the presentation. I'll also share a couple of documents with Anil Garu about uh, um, the two topics of if there was enough time, I wanted to walk through like a vibe coding session of different prompts that I would give. So I'll share those two documents as well, and then I'll let him decide how they get published.
Sir, my one of the question is, hello,
Yeah. Yes, Anil.
could we use this LLM tuning or AI agents application to develop a model writer? See, Vishwanath Satyanarayana, there are so many great writers who died. Or can we develop a writer module?
I think it's
If
already there.
user gives
It-
his choice, it will generate.
No, I think most of those things are already there. So if there is, so generating even content, not just writing. So writings is very nuanced, right? It needs to understand culture. So Viswanath Satyanarayana Garu, I mean, the way he writes or what he has written I don't think it can be imitated or replicated anywhere. In that sense, what is the fundamental and the key to their success and key to their popularity is the cultural background. The current LLMs, they do have some cultural background, but they can't think. I mean, that's the bit. They can't think. They can produce something which will look creative to us because we can think about it. So we can create like a very strong system which can reproduce articles in the style of someone. It doesn't mean that it's actually being creative at all.
Even NTR, ANR, or SV Rangarao, can we get LLM suit for multimedia applications in future?
Yeah. I mean, so as an example, I don't. So there was a recent news that in Hollywood there is an AI actor who has an agent. So there's an actor who they're not real, they're artificial intelligence, and they have gotten the services of a physical human agent to go find them parts in movies, roles in movies. Now and they can do that because that particular AI system probably doesn't have anything of its own. So it doesn't have the aura or the background of a well-established actor. But when we start talking about creating new avatars of existing people, there's a lot of privacy concerns as well. There are lots of safety concerns as well. So most of the time, people don't go the direction simply because of the privacy and safety concerns that are completely embroiled in. You cannot. There's many lawsuits that are happening, especially in the US, about people even using the voice of another known person because they do not want the AI to actually replicate the voice, let alone the words, right?
Specific industry oriented LLM suits are also coming.
Yes,
This,
they are. Yes, they are. Yeah. So when we talk about specific industries, so because LLMs can do a lot of things, but they do a lot of things in a very bad manner if they're not sort of put, if you don't prompt them and if you don't guide them, if you don't nudge them like you have to do it with students and kids, they can go all around the place, right? So the specific LLMs would be very specific LLMs of very high quality, but doing certain types of tasks well in an enterprise context. And if you look at a non-enterprise context, they can do a lot of things decently enough because that's where human thresholds are low.
okay, thank you.
Thank you.
So thank you very much, sir. I think you are running out of time.
Yeah,
Uh,
I am. Thank you for the invite. Thanks for
Email, please,
bearing
sir.
with me. for
Yeah,
all
I
this
will
time.
share everything, sir, including the presentations and email. I will share everything.
Yes, thank you.
Thank you,
Thank
sir.
you, Nagari.
Thank you for sparing your valuable time. And once again, on behalf of APSHE, on behalf of my chairman, Professor K. Madhumurthy Garu, I thank you so much. And we look forward for working with you again and again.
No,
And
thank
I
you.
also
Thanks, Andy.
thank
Thanks a lot.
Dr. Sridhar Garu, C.V. Sridhar Garu, for his help and cooperation in bringing you to this audience. Thank you, sir.
Thank you, Andy.
Thank
All
you.
the best, everyone. Take care.
Thank you.